look at graphing a function, coming up with an equation from real data. It's pretty promising if you're going into a math career, or if you're going to use mathematics, you're going to be making models from data. In this case, we're going to look at the equation y is equal to a cosine b times t minus c plus d. This is the equation we're going to use. I'm going to use cosine because this peak is easier to slide than the zero, because I don't know which way we're going, up in the middle or down in the middle. Okay? So we're going to take this equation and we're going to find A, B, C, and D. A, B, C, and D. So if I take this data here, you notice that 0, 2, 4, 6, and so on. As the time goes by, what happens to my population? Is it always the same? Well, it starts out at 11.1, and then it goes to 12.1, and then it goes to 13. Then what does it do? Then it starts coming down to 11.6, and it comes to 11. Then it goes to 11.6 again, 12.7, and 13. And can you kind of see this oscillating up, down, up? Can you see that? And so from this, we recognize that it's a cyclic sine or cosine type of a graph. So how do you actually find all these? Well, we're going to do a little technique that I like to call high-low, and you're going to find what time in years was this the highest. What year do you think? The first highest. 4. This one? Circle that on your iPad. Circle that 4. That's going to be my high. So at 4, we're going to see a high of 13. Now, where do you see a low? After this, do you see a low? Year 10, right? And so here's my high, and here's my low, and with my year 10, 6, 8, 10, it's going to be my low. 8 and 10. So if I sketch that, it's going to be kind of like that. Is that a full cycle, a full period? It's not. In fact, I would call it half, fourth. What do you think? Kind of looks like a half of one, doesn't it? The green finishes it off. So this is going to be a half of a period. We are ready to find all these. The way we're going to do it is we're going to analyze, excuse me, we're going to analyze what if this thing were split down in here like this. That looks like where it was originally, and then what did we do to it to get it up here? What kind of a shift is that? Vertical shift, yeah. And so to find out what that vertical shift is, we're going to figure it out. How does it compare to the high and the low? Compared to the high and the low, isn't it right in the middle? Yeah, it's right in the middle. And this should be 13 and 11.0. Okay? So if this is 11 and this is 13, where's the exact middle going to be? It's going to be 12, isn't it? Now you can find 12 by taking the high plus the low divided by 2. That's a way to do it. So you might want to write that on the side. Yeah, it's to find D. I always did that the other hour. That's to find D. So if D is 12, and this is my amplitude, from here up to here is my amplitude, or here down to there, it doesn't matter. Both of those are the amplitude. How are you going to find that? Average of those. Well, that will get you D, but we want to find this distance from the middle to the high. What should you do? You can just do the difference. You can do the high minus the middle. Or you could do the middle minus the low. You can do either one of those. 13 minus 12 is just going to be 1, isn't it?
Could it be the absolute value?
You could, yeah. Another creative way that I've seen is they go high minus low. And then divide by what? If your 13 minus 11 is 2, what do you do to get 1? You divide it by 2. That'll get you the right answer too. All of those will get you your amplitude, any of those. Now for B, B is 2 pi over the period. 2 pi over the period. Now the period isn't very hard to see because what you can do is you can say from 4 to 10, that was what part of a period? Half. So here is half of it. If we finished it, another 6, you'd have the full thing. So what's the period for this guy? Yep, it's 2 pi over 12. And so I like to go 2 pi over the period is your B. In this case, it's going to be 2 pi over 12, which is pi over 6. So let's see what we have so far. For my formula, I have y equal to A. A is 1. Cosine of B. B is pi over 6. And then your time minus C plus D, which was lifting up 12. The only thing I don't have is what this shift is. From the original, which was 0, to here, well, what is that? It's 4, isn't it? C is the x value of the first peak. P-E-A-K. And in this case, it's 4. And so this is what I think that formula is going to be. How many of you think that looks like a good formula? Healthy looking, looks good, right? But wouldn't it be cool if we could actually test it to see how well it fit? It's real data. Maybe it doesn't fit very well. Well, we can do that. Take your calculators out. And I saw some of you when you walked in. Maybe it's because you came back from a break, but you weren't in the best mode when you came in. So change that to radian mode, because degree mode is arbitrary. Radian has to do with distance. So if you're in a good mode, you're ready to go, hit stat, and then edit, and put in the data from this table. 02468 for L1, and then the Y values, 11.1, 12.1. You're going to fill those out all the way to the bottom. Radian mode, yep. It's going to let me do this or not. There it is. Good. So you're going to put in all the way to 2468 to 22, and then you're going to put all those values all the way to 11.2. And then when you're done, before you enter that, make sure that you have the same number of items in L1 as L2. Some of you game players who play games on your calculator, you're going to have to change your stat plot to L1 and L2 in your calculation, but we'll get to that in a moment. once you have all of the data put in, you go to second y equals, and you should see number one, stat plot should be on, and it should say X list L1, Y list L2. If you play video games on your calculator, sometimes this gets advanced to L3, so change it back to L2. Then, once you have that, hit zoom 9. That's what your data display should look like if you put it in correctly, and if you hit zoom 9. Okay, that's what the data should look like. And we don't know if that fits or not. We're going to find out if it does. Okay, so now once you have the data display, we're going to see how well our graph that we made, our equation, fits the graph of data. It should fit pretty well. So, but we're going to see. So what you do is you go y equals and just put this in. Now I want to warn you, a little bit of calculator challenge here. We're going to need 2 parentheses to accommodate the pi divided by 6. And then we're going to go x minus 4 and put 2 parentheses on that, because you want pi over 6 times x minus 4 to have the cosine of it. So there's an extra set of parentheses plus 12. And if I did this well, and I'm in the right mode, radian mode, I should be able to hit graph, and it should hit all the points reasonably well. It's a little off when it gets over here, but it was pretty good at the beginning, especially on this high to low that we started with. And there you go. That's how you can take real data, make an equation, and use your calculator to see how well that equation fits. Now you try that with, go down at the end here, you try that with numbers 2, 3, and 4. See what you can do with 2, 3, and 4.